S-Chan presents Educational Video Lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
So now we have calculated what are the waves which are associated with the moving particles. Now when we are taking a solid or the liquid or the gases, so what kind of waves are associated with that materials? Whether the waves are same as that of light waves which are associated with solids in the liquids or then the gases. So that can be defined in terms of acoustic waves.
If you want to study this topic in detail, refer to the book by S-Chan Publishing. Link is provided in the description box.
Welcome to S-Chan Academy. Myself Dr. Narinder Kaur. Now I will explain you the waves which are associated with the solid, liquids and gases. So that waves are known as acoustic. So acoustic waves are when we are applying pressure to the solid, liquid or gases. So they are traveling in the given system in the terms of or in the form of wave pattern. So such kind of waves are known as the acoustic wave. These waves also show numerous characteristics including wavelength, frequency, period, time period and the amplitude. And their acoustic waves are perceived by the ear as a sound. So that means if there is some solid is present over here, so in case of a solid system, when we press this solid system, we know that the solid that is made up of atoms. So that means these atoms, they will be suppressing to each other. So automatically they starts vibrating and they will transfer the energy in form of, and these packets, they will transfer the energy in the form of waves. So that waves which are associated with the particles which are present in the solid or liquids or the gases. We know that in case of an sea, when there the wind flow on the water of the sea, the waves are traveling on it. So these are due to some pressure which are exerted on the given medium. Either it can be solid, liquid or gas. So such kind of waves, they are known as the acoustic wave. Now similar to the another waves which are associated with the moving particle or the light waves, we know that they are having the different characteristics which include the wavelength. So there must be wavelength, frequency or the time period or the amplitude. So depending upon these factors, so these waves, they are also having the same, that means they are also having the same characteristics. They are also having the wavelength, frequency, time period and the amplitude. So say these same factors are present in these waves. Now these waves are also perceived by our ear as a sound. So these waves are same as that of sound waves. Now the wavelength which is associated with a particle, that is given by nu by f. That is a v by f. What is v? That is the velocity of the wave. What is f? That is the frequency of the wave. And this is the wavelength. So same as that of light wave, these sound waves also or the acoustic wave have the same characteristics. They are having a wavelength, frequency, time period and the amplitude also. Okay, now speed of sound waves. What is the speed of sound? We will firstly define it as. What are the sound waves? We know that the sound waves which are basically feel by our eardrum. So that waves are known as the sound waves. Then their speed is defined as the distance which is traveled by the sound wave with the time. The ratio of these two, that is equivalent to the speed of sound waves. That means the speed of sound wave, that is defined as the distance through which a sound waves point, such as a compression or rarefaction. We know that on our ear we are feeling some pressure. So this pressure, that can be compression or that can be rarefaction. So due to this impressing of pressure and releasing of pressure, our eardrum will vibrate. So that's why we are hearing the sound, and the waves associated with sound, that is known as a sound waves. And the distance of such a compression and rarefaction, that which is travelled with respect to time, per unit of time, that is known as the speed of sound wave. And we know that the speed of sound, that will remain same for all the frequency in the given medium under the same physical condition. That means either we are standing in some medium, or we are standing in air, or we are standing without medium. So the speed of the sound waves, that will always remain same. That means medium does not affect it. So the speed of the sound waves, that can be calculated by the following formula. How we can calculate it? We know that the wavelength of sound wave, the lambda, that is equals to V by F. What is V here? They are the velocity of sound wave, and what is F? That is a frequency of sound wave. So by calculating from here the frequency, if we know the lambda of the wavelength, lambda, that is the wavelength of the sound wave, and we know the frequency of sound wave, their speed, that can be calculated. For example, how does it will take long for the sound wave with frequency is given and wavelength is given to travel the distance of 1.5 kilometer. How that will be calculated? We know that the speed, that can be calculated by the lambda into frequency. So by substituting this, we will calculate the speed. Now we want to calculate the time. How longer time that will be travel? So the time, that is equals to distance divided by velocity. So by substituting these value, we will get time over here 2.1 second. So that means the sound waves, they will travel with this much speed over here. Now the acoustic waves are basically the sound waves over here. So that means these waves will require some medium to travel, or in some, their velocities does not affect when we are changing from one medium to the another medium. And when we compress a solid, or when we compress a liquid, or when we compress a gases, we know that their atoms, the distance between the atoms will changes out. That means the atoms will travel, or they will pass the information from one medium, from one region to the another region. And when they pass the information, that information is passed in terms of some waves. That waves are known as the acoustic waves. And when we are speaking something, our eardrum, that will pass information from one media to the another media, and due to the information that is passed in terms of sound. So that waves which are associated with the particle, they are known as the sound waves. And these waves also have the same characteristics as that of the these waves are also having the same characteristics as that of the normal waves or the light waves. We know that they are having the wavelength, frequency, they are having the time period, and time period, that means there is in the 1 second how many waves that can be, or the wavelength or the knobs that can be transferred. So all these characteristics are also associated with the sound waves. So sound waves is one of the example for the acoustic wave. So that means these information, from the given information, we can calculate the speed of the sound waves, we can calculate the wavelength of sound wave or the frequency of sound wave. So these can be calculated by using the formula lambda, that is the wavelength of sound wave, V is the velocity, and F is the, or nu is the frequency of the wave. So by using this formula, we can calculate the speed or for the time by which the sound waves, they are traveling in the given system. So that can be calculated. So that means the acoustic waves, they are just similar to the sound waves, or which are affecting the given system. And also the sound waves, that will remain same for all the frequency. That means when we are changing the frequency of the given medium, the sound of that waves, that speed, their speed is not affected by the frequency. So that means as the frequency is changing, the lambda, as per that lambda will be changing. So the speed of the sound, that will always remains constant. That is same as that of velocity of light. We know that the velocity of light is always constant. So that is constant throughout the system. But the sound wave, the speed of sound wave, that also remain constant in the given medium, but with the different frequencies. But when you change from one medium to another medium, the speed of the sound waves, that can be changed out. So we will take a short break over here. So we have been studied what are the acoustic wave and what are the speed of sound waves. The sound waves which are associated with the particles when we compress a solid, liquid or the gases. So how their speed is changing in the given medium, and it remains constant from one medium to within the given medium, and the frequency is changing, and the sound waves are changing their speed when we are traveling from one medium to the another medium. Now after the break, we will study the factors which affect the speed of light.
Now quality learning is easily available at your doorstep. S. Chand Academy brings detailed lectures based on AICTE curriculum as per the New Education Policy 2020. So do not forget to subscribe to the S. Chand Academy and access the wide world of knowledge conveniently sitting at your home. Stay connected and keep watching S. Chand Academy. Happy learning!
Welcome back to S. Chand Academy. Before the break, we studied what are the speed of sound waves, what are the sound wave, what are the acoustic wave. Now we will calculate, we will understand on the factors the speed of the sound wave will depends, whether it remain constant or whether it depends on which factors it will depends. So now we will understand this. Describe the factors which affects the speed of sound. Now that means the speed of sound we have been understand till now. The speed of sound that is given by factor V. We know that here the lambda is equals to V by F. So speed of sound that is equals to lambda into F. What is lambda here? That is a wavelength of the sound waves. And what is nu frequency? That is a wave frequency of the sound waves. Now we want to describe on what factors this speed of sound will depend. So speed of sound will depend upon the density and temperature of the medium in which the sound waves travels. They will affect the speed of sound. So how it will depend upon the density. So speed of sound, we know that how the sound travel from one place to another place. So when there comes density means there are a large number of, for example, when the large number of people are present in a single or in the short room and all they are speaking. So no one can understand what the single person says. So that cannot be understood. That means the density that will affect the speed of sound, how it travels. Second one is the temperature of the medium. So automatically when there is a higher temperature of the medium, so we know that the sound waves also depend upon the propagation medium, in the medium in which these waves are propagating. So it will depend upon that. So when there is a temperature is higher, so automatically the speed of the sound that will be get affected. So automatically when the temperature is very low, the speed of the sound that will travel slowly over here. So with the temperature, the speed of the sound that is get affected means the particle, they will pass information from one region to another region very quickly when the temperature is higher. While when the temperature is lower, the particles immediately cannot transfer information from one medium, or you can say that from one region to the another region. So this is the known as the how temperature and density will affect the speed of sound. So now how the density affect? When the medium is dense, the molecules in the medium are closely packed. We know that when the medium is dense means its density is high. Dense means the number of molecules per unit volume, they are very high. We know that density that can be defined as, that is the number of particle per unit volume. So it is defined as number of particle per unit volume, means higher the density means higher will be the number of particles per unit volume. More will be the number of particles in the given volume. So automatically the sound wave that will travel faster. Therefore, the speed of sound that will increases as the density of the medium increases. Means there are no gaps. Large number of particles are present. If that means in this, if there is a, here there is a 2 or 3 particles are present, or if in the given system all the particles are closely packed. So large number of particles are present over here. That means now in this case the information can be easily passed through the system. So information from one to another place, because the gap is very small over here when the large number of particles are present. Here the gap is large, so particles are smaller, so automatically the information cannot be passed in this case faster as comparison to this case. So automatically the speed of sound that will be, if this is the first case and that is the second case, so automatically Vs2 in the first case, second case, that will be more than the speed of sound in the first case due to presence of large number of particles. So that's why when the medium is dense, that means large number of particles are present in the given system when they are closely packed. So the sound waves, they will travel faster. So the speed of the sound that will increases as the density of the medium increases. So second is a temperature effect. What is the effect of temperature? Now the speed of the sound that is directly proportional to temperature. So that therefore as the temperature increases, the speed of the sound that is also increases. So this implies the speed of sound that is directly proportional to temperature. We know that when the temperature goes on increasing, so automatically speed of the sound that also goes on increasing. So why this is so? Because when there is more temperature, there will be easy for the particle to transfer the information or to transmit the information from one region to the another region. So information that can be transferred very quickly. So automatically if there is a quick response to the information that can be transferred, so automatically the speed that will be very large. So speed of the sound that will be more or it will increases when the temperature of the given system increases. So now next is the speed of sound in different media. Now all this thing is within same medium. When the medium is same, the density is large and the temperature is large within the same medium, the speed of the sound goes on increasing. When the density goes on increasing, and second one when the temperature is goes on increasing. So these are the two effects which affect the speed of sound that is within the same medium. Means when the medium is same, in the first case when we are increasing the density, and second one when we are increasing the temperature, in both of the cases the speed of the sound that will be enhanced. Now in the second case when the speed of the sound in different media, now the speed of the sound depend upon the density and elasticity of the medium through which it travels. We know that when we are taking from one media that is a more dense and second media that is a lesser denser, and when the speed when the sound travel from one media to another media, so depending upon the density and also depending upon the elasticity, its speed that can be increased or decreased. So when the sound waves are traveling from one media with higher density to the another media with lower density, their speed will be slowed down. So that means in the different media, when the sound waves are traveling from one media to another media with the smaller density or with the higher density, so depending upon the density of the medium, the sound wave speed that can be changed out. Second, the sound waves travel in the faster in the liquid than in the gases and quicker in the solid than in the liquids. Now greater the elasticity and the lower the density, faster sound travel in the medium. Now in the first case, the sound waves travel faster in the liquids than in the gases. Now why this is so? We know that here in the first case when the medium is same, when the medium is same, so there are the two factors. One is the density and second one is the temperature. So that implies when the density is large, so more the density of the medium in the same medium, that means if density is more, so that means speed of sound that is more. Second factor is the temperature. That means when the temperature rises, the speed of sound is, this is a Vs, that is also increases. So that is within the same media. So that means now when the density is more, if this is represented in D, if D more, then the velocity of sound more. So both the factor when the density increases or the temperature increases. So that means increase means it is high up and the temperature increasing, velocity of the sound waves that is also increasing with the same media. Now second case is that when the sound wave travel from one media to another media, then more denser is the media, more will be the speed of sound wave. That means more denser means for example, in solids, there are three mediums: solid, liquids and gases. So there are the three kind of media are present: solid, liquids and gases. We know that solids, they are more dense. More dense means density of the solids, if this is ds, density of the liquid is dl, and density of gases is the dg. Now we know that ds is more than dl and that is more than dg. So this is the density of solids, liquids and gases. So that means if their density is more, automatically speed of sound waves in solids, that is more than speed of sound waves in liquid, than the speed of sound waves in gases. We know that why this is so, because the more density of solid means more will be the number of atoms, they are closely packed to each other, and if there are more atoms, the information from one end to another end, the passing of the information from one end to another end, that will become easy. So automatically this information that can be easily passed out. So more is the density of this solid, implies when the sound waves travel from one media to another media. For example, sound wave travel from solids to gases. So automatically their velocity will be more in the solid than in the gases. Now second part, make the density same. Now next is the density is same and elasticity is different. Elasticity of the system is different. Now density is same, lesser the elasticity. If elasticity of the system is smaller, higher will be the sound velocity of the sound waves. Now why this is so? Now lesser elasticity means information can be traveled, passes from one system to another very quickly. So that means quickly information that can be passed out. So lesser is the elasticity, higher will be the velocity of the sound waves. So these are the things, that means when the sound waves travel from one media to another media with different elasticity and the same density. So depending upon the factor, the system which are having the lesser elasticity and the same density, so the higher will be the velocity of the sound wave. So these are the primary factors on which the speed of the sound waves that will be depend. So the sound waves will travel faster in the liquids than in the gases, automatically quicker in the solids than in the liquids, because the solids are more dense than the liquids or than in the gases. Now greater the elasticity and lower the density, that means if elasticity is more, in that case the faster the sound wave travels in the media, means if in the given media elasticity is more and the density is lower, if the elasticity is more and the density of the system that will be lower, so in that case the sound wave that will also travel faster in the given media. So these are the primary factors on which the sound waves that will travel or speed of the sound waves that will be got affected. Means when the sound waves travel in the same media, so depending upon the density and temperature, so that will affect their speed, and when the sound waves travel from one media to another media, density then elasticity, these two factors will affect their speed. So affect the speed of the sound waves that will be get affected by the elasticity, density and also by the temperature. So these are the factors by which we have been understood, key factors on which the speed of the sound waves that will be get affected. So that is get affected by the density of the given media, elasticity of the given media and also temperature of the given media. So when the temperature is higher, speed of the sound wave is higher, density is more, speed of the sound wave is more the elasticity, lesser the density, the speed of sound waves that will be large. Thank you.
If you want to study this topic in detail, refer to the book by S. John Publishing. Link is provided in the description box. If you found our video interesting, please like, share and subscribe. And do not forget to press the bell icon.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.